In this video, we will learn some important reactions of alcohol, phenol and ether. The first reaction is when an alkene, say propene, react with water in presence of acid, addition of water takes place according to Markovnikov rule and the product is alcohol. Negative part of water, say OH minus, goes to that part of carbon which is less number of hydrogen, and this H plus goes to that carbon which is more number of hydrogen. So the product is propane to all. This reaction is called acid catalyzed hydration reaction. Second reaction is when an alkene, say propene, react with first diborane B2H6 and then followed by reaction with hydrogen peroxide in presence of base OH minus, it gives alcohol, but here propane 1 all is formed. You can remember the reaction. This if you add Markovnikov addition, anti-Markovnikov addition of water here, so this negative part goes to here and this positive part goes to this carbon. Okay, so you can remember the reaction like this. Third reaction is when an aldehyde, say propanol, react with hydrogen in presence of palladium, it gives alcohol. When an ketone, say propanone, react with NaBH4, it gives secondary alcohol. Okay. When an carboxylic acid react with lithium aluminum hydride, the product is alcohol again. In these three reactions, you see that the reduction of aldehyde, ketone and carboxylic acid takes place. Aldehyde give primary alcohol, ketone give secondary alcohol, and carboxylic acid also give alcohol. It may be secondary, primary according to the what we have taken carboxylic acid. And here the reducing agents are strong reducing agent is lithium aluminum hydride that convert carboxylic acid to alcohol, and the mild reducing agent is hydrogen in presence of palladium and sodium borohydride. You can note here that all the reducing agents contain hydrogen. Reduction and oxidation of alcohol, aldehyde, carboxylic acid can be remembered by the sequence like this. Alcohol when oxidized it give aldehyde from primary alcohol, and then further oxidation it give carboxylic acid. Secondary alcohol, when oxidized, it give ketone, but further oxidation cannot takes place. But if you do reverse to the oxygen, means if you want to make aldehyde from carboxylic acid and from aldehyde to primary alcohol, then you have to do reduction. Okay, similarly here. So you can remember here the sequence of reaction. Next reaction is when an aldehyde or ketone react with Grignard reagent. Say I am taking here methyl magnesium bromide. Grignard reagent is a polar bond between magnesium and carbon. Magnesium is del plus and carbon is del minus. Okay, so here in aldehyde or ketone, this C double bond O bond can be shifted to oxygen, and oxygen become electron rich and carbon become electron deficient. So this CH3 minus of Grignard reagent goes to carbon electron deficient of aldehyde, okay, and this oxygen attract magnesium bromide. So the product is O MgBr and then CH3 CH3 CH3. Okay, so one of the CH3 come from Grignard reagent. This reaction is a step up reaction. If you want to increase carbon compound in the product, then you can use here, you can use this reaction. And again, further hydrolysis of this addition product will give alcohol. Okay, so let's start the reactions of Grignard reagent with different aldehyde and ketone. First of all, we will do the reaction of methanol with Grignard reagent. Okay, the mechanism is same here also, del plus, del minus, this will shift and this will attract here. So the addition product is OMgBr, then H, and this become CH3. Now this further hydrolysis HCOH H CH3. So this is in primary alcohol. So if you want to make primary alcohol by Grignard reagent, then you have to do the reaction with methanol. Okay, and the common name of this methanol is formaldehyde. Okay, methanol is an IUPAC name and the formaldehyde is a common name. Now we will do the reaction of Grignard reagent with aldehyde but other than the methanol. So I have taken here ethanol, and Grignard reagent is CH3MgBr. So del plus, del minus, again this will shift and it come here CH3COMgBr, and then it is again CH3H. This is an addition product, and then further hydrolysis it will give OH HCH3. This is an secondary alcohol. So, from aldehyde other than methanol with Grignard reagent, it gives secondary alcohol. Now, if I take ketone with Grignard reagent, then let's see what happened. This is del plus del minus. This is again now the here addition product, and then further hydrolysis, it will give an alcohol. So this alcohol is a tertiary alcohol. So if you take ketone with Grignard reagent, then it gives tertiary alcohol. Next reaction is reaction number 7. When an alcohol react with sodium, it gives sodium ethoxide plus hydrogen. Next reaction is phenol also react with sodium to give sodium phenoxide. This is sodium phenoxide plus hydrogen, and this is sodium ethoxide. Phenol also react with sodium hydroxide to give sodium phenoxide plus water. But alcohol do not react with sodium hydroxide. These three reactions show the acidic property of alcohol and phenol. Next reaction is when an alcohol react with concentrated H2SO4 at 443 Kelvin, then alkene is formed. This is a dehydration reaction. This concentrated H2SO4 is a dehydrating agent. So it removes water from the alcohol like this. If you write the alcohol like this, then it removes alcohol. It removes water from here, and then carbon-carbon double bond is formed.